As you're getting your notes out, again, flip to 2.4. We're going to talk about one really important vocab word before we dive into it. That important vocab word is included angle. What it says is the angle formed by two sides of a triangle. I like to think of it as the angle in between two marked sides. If we look at this diagram here, let's get an example. We have this side and this side, right? And they're marked. That has two tick marks. That has one tick mark. What angle is in between those two sides, those two tick marks? What is it? Angle P. That means angle P is our included angle. It's in between those two tick marks.
Look at the vertex.
Nope, I can something different. It doesn't have to be in between two tick marks. The included angle is an angle in between two tick marks. That can be the vertex. That's a good indicator of where it's angle. Doesn't have to be that. Questions over that? Our first shortcut is what we call side, side, side. We abbreviate it with 3 S's. Okay? What this stands for is the 3 sides of one triangle are congruent to 3 sides of the second triangle. And those 2 triangles are congruent. So the 3 sides match up. If you have tick marks on all 3 sides, those tick marks match up, they're in the same spot, then you know that those 2 triangles are congruent. So rather than finding out that all 3 sides are the same, that all 3 angles are the same, once you have that the 3 sides are the same, you're done. You know they're congruent. Okay? A second shortcut is side, angle, side. We abbreviate it with SAS. And what that says is if 2 sides and the included angle so the angle in between those 2 sides of one triangle are congruent to 2 sides and the included angle of another triangle, then those 2 triangles are congruent. So you just have to show that 2 sides are the same and the angles in between are the same, and you're done. You know the 2 triangles are congruent. What we did last week, what was on your quiz, and what we did at the beginning of class, was you had to show that 6 parts of a triangle were congruent. You had to show that all 3 sides and all 3 angles. Our shortcuts, we only need to know 3 parts. And today we can either show that all 3 sides are the same, or a side is angled than a side. Okay? By the shortcuts, you have to show less stuff. It's the same. Questions over that? We look at example 1. We want to use those shortcuts to determine if these triangles are congruent. Okay? What I like to do, I always start on a side. I just pick any side that has a tick mark. I'm going to start with this side. That side has a tick mark. Start there. If we move and go this direction, there's nothing marked. There's not an angle, there's not another side, there's nothing. So that direction is not going to help me. I'm not going to move that direction. Okay? I'm going to move the other direction. If you notice, we went from a side to an angle. Then we keep going, we move to another side. Okay? We went from one tick mark to an arc to another tick mark. We would then have to go to our other triangle and follow that same exact pattern. Right? Well, again, I'm going to pick this side. If I move in this direction, there's nothing there. There's no angles marked, there's no sides marked. I'm not going to move in that direction. Okay? I'm going to go this way to this angle. So I go from a side to an angle to another side. One tick mark to an arc to one tick mark. Did we follow the same exact pattern in both triangles? We went from one tick mark to an arc to one tick mark. One to an arc to 1. Did we follow that same exact pattern? Yeah, so can we say that these triangles are congruent? Yeah. Which shortcut can we say we used? Should we side, angle, side? We went from a side to an angle to a side, side, angle to a side. Right, we're done.
This one's a little weird because it's an isosceles triangle, but normally you can see the difference. Normally you go from like 1 tick mark to 1 R to 2 tick marks, so it makes it a little bit easier to see. But this way, it doesn't really matter because it's an isosceles. Another example might be different.
We look at B, here we go. We got different tick marks on the line. And I'm going to start with a side. I'm going to start right here. If we look, if I go this direction, there's nothing there. Nothing's written, nothing's marked. That's not going to be helpful. So you need to go the other way. I'm going to start with this side. I'm going to go from this side to this angle to this side. So I went from 2 tick marks to 1 arc to 3 tick marks. Okay? We have to follow that same exact pattern in the other triangle. We have to go from 2 to 1 to 3. Okay? Well, here we go from 2 to 1 to nothing. Do we follow that same pattern?
No.
No. So can we say that these triangles are congruent? No. So there's nothing. Not enough information. None. Can't say that those triangles are congruent. Can't use a postulate. Some of you might be thinking, well, it goes from 2 to 1 to 3 over here, but they have to be in the same spot. So because there's nothing written here, we skipped it. It does not follow the same exact pattern. Okay, they all have to be connected, all right in a row. 2 to 1 to 3, 2 to 1 to nothing. Doesn't match. Questions over that?
Order matters. Some of you may even look at it and say, well, that's got 2 tick marks, 3 tick marks, and an arc. The other one does too, but it's not in the same location, not in the same order. They have to be identical in order to be congruent.
Question.
You go back and get enough of the.
We'll come one time.
One time. Won't go back again. And this last one and this third one, this is a special type of triangle. We call these shared side triangles because they're sharing a what? A side. This middle side right here, it's in both triangles. So we can say that it's congruent to itself. That middle side is the top triangle, and the middle side is in the bottom triangle. So it is congruent. It's in both triangles. Okay. Well, again, start with a side. I went from 1 to 2 to 3. Go to that other triangle. 1 to 2 to 3. Did you follow that same pattern? Yeah. They all have the same amount of tick marks on the sides. What shortcut can we say we use? Side, side, side. We have all 3 sides the same. Side, 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 side. They're all in the same spot. So we can say those are congruent by side, side, side. Questions over there? You ready to prove our first one using these shortcuts? Yeah? Go ahead and write your statements and your reasons for filling in your skeleton.
Everyone should have guaranteed at least 3, if not 5.
Oh, no.
I'm doing this because of the practice. If you leave this blank on the quiz or test, you're not helping yourself. There's 3 guaranteed you have. That's really all of them. If you follow the rules and know the patterns, you will have every single answer without even really knowing how to do the problem. Just following the shortcuts. All right. Start with number 1. I think we got that. What's the number 1 statement going to be? Who can give me that?
Given.
The given. So what is the given?
Given.
Correct. What is that given?
1 J A
Segment JA, yep. Correct, Moon Day. Very good. I'm going to abbreviate, but A is a midpoint of DM. Segment DM. Good. The reason always is going to be what? Given. Look here it says, given. So there it is. We got that. There's 2 points right there out of it. Now, one more information you can automatically do is going to be what? Sam, what's another thing you get off this? Free. The proof. I don't know the number, but I'm going to put it down there somewhere. I'll say it right down here. So triangle JAD is congruent to triangle ZAM. All right, good. There's 3 points off the bat. And maybe even more if we look at our picture and figure out what's going on here. Well, let's make sure. Once I have my skeleton written down, it's 3 free points right there. Now I'm going to see if everything's marked correctly. So JA is congruent to ZA. Is that marked? Yes, it is marked. A is the midpoint of DM. There's nothing on the mark on DM. But we also have a key thing here. What does this tell us right here? This word, this English word, this human word. It is, but it's going to tell us a certain reason based off this. You're right. You're exactly right, Kanisha. But whenever I have a vocab word, what's that? Put a red flag up. That's going to be one of my reasons.
Look at a muscle, look.
What is it? Definition of that vocab word. Very good. So number 2 is going to be definition of that vocab word. So def of, what's my vocab word? Midpoint. So def of midpoint. And can I just say some good stuff? Saying it bisects. What's that really mean? It cut in half. What do I know about each of the pieces? They are congruent. So I'm going to go ahead and mark my diagram. Since there's already 2 tick marks taken, I'm going to just go to 1. Now all I got to do is name those segments. Well, what segment are each of those little tick marks? Give me the one on the left. What's this one? How would you name that segment?
DA.
DA. All right. And again, it doesn't matter how you name it. Just be consistent. So segment DA is congruent to what other segment? MA. Very good. You want outside in, outside in. MA. Awesome. Nice job. Let's stop a second and look at this. Remember, if I'm trying to do a shortcut, I need to have 3 pieces in each triangle. So I covered up right now. Now look at the triangle JAD. Is there 3 pieces listed that I have right now? Is there 3 pieces I have marked yet? No, I got 2 sides right now. Either figure out that other side or figure out an angle. So let's think about this a second. Back to the very first problem we did it. Is there some sort of special relationship these 2 triangles have with one another? What do they look like? They are bow ties. The bow ties always have what kind of angles? They're vertical angles. So anytime, this is what I'm saying, it's kind of a freebie. You have these 3 initial ones, you know off the bat, you know what they're going to be. Then anytime I see that these are bow ties, I know one of my reasons will always be vertical angles. So vert angles are congruent. Vertical angles are congruent. Now we got to name those vertical angles. And we said vertical angles always have 3 points. I will do the hard work for you to name the first one. I'm going to say, and again, the vertical angles are right here in the middle. Always mark their diagram. I'm going to say angle JAD is congruent to what other angle? Order matters here. ZAM, correct. I went across the 2 ticks, 1 arc, 1 tick. Do the same thing on the other one. 2 tick marks, 1 arc, 1 tick. So I'm going to say angle ZAM. Cool. Stop. Look at one triangle. Just cover it up with your hand or whatever you see. I'm looking at the triangle on the left. Do I have 3 pieces marked? Do I have 3 pieces marked on my diagram? So now I can see if I have a shortcut. Now let's figure out what 3 pieces I have. Start at the furthest most point, whether it's an angle or a side. I'll start up here with the 2 black tick marks. So that's a side. I can't go this way. Not allowed to go that way because there's nothing there. So I'm going to have to go the other way. So I'm going to start with this one, the black tick mark, go to the green arc to the red tick mark. So I go from a side to a angle to a side. Let's see if that's the case over here on the same exact way. So I started at the black double tick mark there, went to green, then went to red. So do I do the same thing here? Black double tick mark, green arc, red tick mark. So yes, are they the same? Are they in the same location? So guess what? Now I can say my triangles are congruent. So you don't have to move it. I'm just going to move it up so you can see it. But number 4 is to saying that they are congruent. Why are they congruent? What shortcut do we have?
Side and side.
Side, angle, side is correct.
Oh, it is so cold.
Now, this is what I'm saying. If you get good at this, you automatically know what it is off the bat. Because you already have the black ones, the skeleton part. I know up here, I had a vocab word. Anytime you have a vocab word, what's the reason? Definition of that vocab word. There's another reason. Over here, what type of triangles are these?
Rainbows. I mean, bow ties.
Bow ties. What do bow ties always have? Vertical angles. And then if I march my diagram, oh, I have already sides there, side, angle, side. I know I have a reason here, and I know that's my last step. You basically have everything done without really knowing how to do this. If you just follow the patterns.
Oh, it's easy.
Or it is easy. You guys may impress yourself when you do your practice later. I forget who it was earlier today. He's like, man, I didn't think I could do this. It's super easy. All right, let's try another one. This is written a little bit different. You guys can get the skeleton. Just watch how you're reading this. It says, write a two-column proof to show that triangle QRS is congruent to triangle STQ, given that RQ is congruent to TS and RQ is parallel to TS. Now, the reason why I say this is because it's written backwards. The proof is first and then the given second. So let's be careful with it. Everyone right now, this moment of time, write out that skeleton. Write those 3 things you know every single time. I know this is going to be a statement. I know this is the reason. I know this is going to be 1. You should be all doing the skeleton, getting going. Because if you leave this blank, again, I know it's silly, but we had some crazy people leave it blank. How you leave it blank? There's 3 free points. That needs you to say, I don't care, I'll see you next year. That's what you're telling me. We'll see you next year. I ain't scared. All right. So, what's going to be my first statement?
Given.
It is the given. What is the given?
Given.
It's the second thing back here.
Oh, I did the wrong one.
That's why I'm saying you got to be careful, because it says prove that. So it's going to be RQ is congruent to TS. And the other thing is RQ is parallel to TS. Now I'm not going to write the word parallel out, because we have a shortcut for that.
The line.
The thing that looks like an 11. Parallel lines to TS. So those are my 2 given informations. The reason we always know is going to be given. That won't change. And the last bit of the skeleton I can do is what I'm trying to prove. That triangle QRS is congruent to that. I'll write it down here. Make sure I said it right. RS is congruent to triangle STQ. That's what I got. Move up a little bit. All right, so there it is. Don't know the number, I'll put it down later when I figure it out. Now let's go through that process again of what we do. All right, I want to make sure that all my information I was given is marked. RQ, is anything marked in my diagram right now?
Nope.
Nothing's marked. No arcs, no tick marks, no nothing. All right, so we got to mark this. Over here, we were given initially J, A, and Z. Those were marked. We had to mark the other thing. So we got to mark everything we see here. RQ is congruent to TS. Awesome. I'll mark that. RQ, TS. They're congruent to one another. Also, I know that RQ is parallel to TS. The more we do this, it'd be a red flag. But right now, we're just going to say yes, yes. Those arrows mean that they're parallel to one another. So they'll never ever cross. Again, that's going to be a reason, one of those shortcuts that we go through. All right, that's all I'm given. That's all I can do right at this moment in time. So I'm going to go ahead and do the next step and think about what's going on. The next thing I think about is, what type of triangles are these? Back here, you said bow ties. Bow ties always had, Sam said, vertical angles. That's correct. These are not bow ties, unless you go to a weird-looking bow tie place. That is not a bow tie. But what are these type of triangles? It's what we talked about the first thing today. Megan? Same shared side. Yep, the same side, shared side. They're sharing that same side. So what side are they sharing? QS, very good. Now, this is where it takes a little bit of thinking here. If I think about these triangles, they're oriented different ways. If this is a triangle and I rotate it, it goes upside down. So if I say this one is QS, what will it be called in the other triangle?
QS.
It's upside down.
That's Q.
There we go. It'd be the other way around. So they call it, again, it just matters how the triangle is oriented. Sometimes they're sitting back to back. Like if I think if I cut a pyramid in half, if I make a 3D and put it together, and then slide it together two-dimensionally, that side they're sharing, that would be the same exact side. When they're rotated like this, they're not. So I'm talking about if I had two triangles look like this. All right, this side would be shared, but they'd be the same exact side. All right, so what is that called? So just like when bow ties always have vertical angles, shared sides always have this property. And I like to think of this property as it's what they're sharing the same thing. It's kind of the similar thing, but sometimes backwards. So I use this example. You guys wake up in the morning. You guys look in the mirror. What do you see? Your reflection. So this property is when I'm sharing the same side, it's called the reflexive property. So reflexive property. So that's another of our shortcuts. Anytime you see shared side, automatically, boom, I know one of the reasons is going to be reflexive property. Always. Always, always, always. And then again, I have to mark my picture as being reflected. That's being reflected. Reflexive property, there's my pieces. All right, moving on. I like to stop each step to make sure I don't do more than I have to. Just cover up one triangle, look at it. Do I have 3 pieces marked in one of my triangles yet?
Yep.
No, the parallel thing doesn't count. I only have 2 sides marked. I need another angle, I need another something I need in there. So I got to figure it out. How do I do it? There's one thing we have not talked about, and it's just parallel. Anytime, again, that helpful hint, just like I have vertical angles, I have shared side triangles. Anytime I see the word parallel in there, it's not going to be definition of parallel, even though it's a word, I realize that. The reason is going to be this. It is always, 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 90% of the time, going to be alternate interior angles congruent. And you're saying, why is that? I'll show you. Parallel means this, that 2 of those lines will never ever touch. They're crossed by a transversal. So we'll see it here. Sometimes you have a hard time seeing it when it's not oriented horizontally. There's one parallel line, there's the other. Do we agree on that? Those are parallel based on what it told me in the initial thing. This is my transversal. It's cutting it. See what I'm through there cutting it. Well, I say it's alternate interior because we know all those properties we learned about, those 5, 6, I don't know what it was. There's 4, but then the 2 vertical angles and same side interior. All those properties we know are applied. They're true now. So I know the alternate exterior congruent, I know this corresponding congruent, same side, or supplementary, all that good stuff I know. Now, the reason we say it is alternate interior is because I know that this angle that touches the parallel line of the transversal will be congruent to this. So now I can say those angles are congruent. Now I just have to name those angles.
Angle Q and angle S.
No, we got to go. We want Q in there. I want to start this. I'll name the first one to help you see it. It's going to be RQS is congruent to what angle? Now, again, how did I go about this? Yeah, we're talking about angle though. We could call it triangle QS, depending on what we want to call it though. But I want to talk about this angle up here, so that needs to be in the middle. That needs to be my vertex. So you could have called it SQR if you wanted, but I just went like that. So I went RQS. I went to the black tick mark, to the green arc, to the red tick mark. So that same pattern, name it in the other triangle. So I went from the black to green to red. So what would be the other side of that angle called? What is it? TSQ, yep. I went across the black tick mark to the green arc to the red tick mark. So yes, it's going to be TSQ. Okay, that's it. Again, I'm going to stop. Do I have 3 pieces marked in each of those triangles?
Yes.
What 3 pieces do I have?
The side and an angle.
Let's go in order though, but you're right, I have 2 sides and an angle. But if I start here this black one, work my way around to the green one, work around to the red one. So I've got a side, angle, side. Let's see if it's the same over here. Side, angle, side. So yes, I have enough shortcut pieces. So now, no way. Of course it did. I was going to go out here and name it. So this is point 4. And my shortcut is going to be side, angle, side. And before you put it away, start thinking about this. Again, those things in black, those 3 original things in black, automatically have those. If I know these are shared side triangles, I automatically know it's going to be reflexive property. Anytime I see parallel, we'll do more examples of this. You automatically know one of the reasons is alternate interior angles. And anytime I know it's going to be a shortcut. So it's either going to be, you don't know the other shortcuts, but it's either going to be side angle side, side side side, or CPCTC. That's usually going to be the last step. So that's it. Okay, questions on those? Okay, I keep that out so you can use as reference.